From this video on, I will teach you how to sketch lots of different types of graphs, and it will be strange. So you have to watch lots and lots and lots of examples, which I will do for you. But just watch lots and lots of examples. It won't make sense at first, but after a while, hopefully it will make sense. But you just got to watch lots of examples. So here, how would you sketch this graph here? Because here you've got, if you look at this here, the graph is here. If you look at x squared will look something like that. And then this bit here is really a straight line. The intercept is at 7, and then it has a gradient of 3. So it would be something like this. So here you've got two personalities, if you like. X squared, and you've got a straight line. So how, if you were to sketch this line, what will it look like? Okay, so in order to answer this question, let's try and investigate it like this. So you've got yourself a graph here. Let's try and investigate what happens when x is small around this region here. Okay, so when x is small, look what happens. Okay, x is small, so create a table like this. So we are trying to investigate what happens when x is small, meaning just around this region here, between -1 and 1. Okay, so let's try and investigate what happens when it's between -1 and 1. Now, if you put, this is x here, 0, put 0 into the x. Okay, if you put 0 into the x here, this term here equals 0. This term here equals 0. So this here, you can see, when x is 0, this term here is really, it vanishes. It's nothing in comparison to these two terms. Okay, let's combine these two because we are good at drawing straight lines, and this is a straight line. Okay, let's split this equation up into two parts like this. When x is 0, you put 0 into here. This thing here becomes 0. This thing here, it becomes 1. Now, when x is small, you see 0 compared to 7. 0 is really nothing. 7 is more important. So when you try and plot this, it will look something like this. When x is 0, 7 is well, it will cross at 7. Okay, hang on, bear with me. Now, when x is 0.5, if you put this into here, this would be 0.25. Okay. Now, if you look at this term here, if you put 0.5 into here, it would be, this part here will be 1.5 plus 7. You see, when x is 0.5, this bit here is negligible compared to this bit here. So this is nothing in comparison to this term here. You see, this is 8.5, and 8.5 is a lot more dominant, or a lot more important, or a lot bigger, or a lot more significant than 0.25. So you see, when x is small, this part here is dominant, and this here is negligible. So you can pretty much forget about this bit here. Okay. Now look what happens when x is really big. Let's say when x is 100. Now put this into here. When x is 100, this thing here will be 100 times 100. So 100 squared will be 1, 1, 2, 3, 4. It would be 10,000. Okay. Now look at this term here. When x is 100, this will be 300 plus 7. So which is 307. You see, when x is 100, this term here is nothing in comparison to 10,000. This 10,000 here will be a lot more dominant than this term here. So when you try and sketch this line here, you see, when x is small, when x is in the region of between, let's say between -1 and 1, this term here is dominant. And when x is really big, like let's say 200, if you put 200 into here, it would be 40000. If you put 200 into this term here, it would be 607. You see, 607 is nothing in comparison to 40,000. So when you try and sketch this line here, hang on, let me, yeah, when you try and sketch this graph here, it will look something like this. Hang on. You see, when x is small, it will adopt this personality here. So it has an intercept of 7 and it has a gradient of 3. So let's just guess the gradient of 3 to look something like this. Maybe steeper. I'm going to guess something like this. Okay. Now when x so this is when x is small around here. Okay. When x is big, let's say over here somewhere and over here somewhere, it will adopt this x squared personality. So it will look something like this. It will follow the hang on. It will follow the x squared curve. Something like it wants to follow that. But when x is small, this bit here dominates. So you could combine the two. So so it will look something like this. Okay. So hang on. Let me do it. Let me do it again. So when x is small, hang on. When x is small, let's say this is 7 here, 7, and it has a gradient like this. But when x is big, meaning somewhere around here, we don't care what's in the middle, okay? We're only looking at when x is small and when x is big. So when x is small, it's going to adopt this personality here. When x is big, it's going to adopt this personality here. So, okay, when x is small, it's going to be intercept of 7, gradient of 3. I'm guessing the gradient of 3 to look something like this. Now, when x is big, well, when x is big, it wants to follow this personality here, the x squared curve. It wants to do this, okay? But because now you're combining the two, so I'm going to guess it. It will look something like this. But hang on, I've got to combine this x squared curve here with this line here. So I'm going to guess. Hang on, it's going to follow something like this. Okay. So when x is big, it wants to do the x squared. That's why it's like this. When x is small, it wants to do this. So I'm just going to guess. I'm going to guess it to I'm going to guess it to be something like this. It's got to be a nice curve. Well, I can't. It's really hard to draw a curve on this computer. It's going to be like that, something like that. Maybe hang on. Maybe it would be something like this. Going through that line. Hang on. Let me try and do it again. Something like that. Okay. So get yourself a graph plotter from the internet and punch this in, and then it should give you a curve, something like this. Well, sorry, it has to go through this line here, and just guess roughly when it's big. Well, I know at the moment it doesn't make much sense, but let me give you let me give you lots more examples in the next video, and then you get a rough idea. Okay.